TV documentaries.
Hi, good day, everyone. Now, let's do some physics. Now, today what we're going to focus on is looking at how can we answer some multiple choice questions. And at this point, some people might think in multiple choice is one of the easiest type of exams to do. But truth and in fact, a multiple choice exam is an exam where you have to be thoroughly prepared for. In that case, where you have to be, you have to know every bit of information for throughout the entire syllabus, right? And what I'm going to do now for you is that we're going to look at a couple questions from a past CXC paper, and we're going to look at how we can acquire to get these answers using looking at the different options, right? So in this case, we're going to decipher how we can get the most appropriate answer, right? Good. So what we will have here, we're going to be looking at a past CXC paper. This paper here, as you can see, is a 2012 paper, 2012 multiple choice paper. Good. So we're going to be going through it step by step. Now, number one, it says when used in front of a unit, the prefix mega means, and as you should know, mega is represented by 10 to the 6th power. Good. So in this case, our answer there should be D. Good. Option A, it says 10 to the negative 6. That negative 6 is actually micro. 10 to the negative 3, that is milli. And 10 to the positive 3 is actually kilo, right? So, like when you talk about mega million, the keyword mega, you could think mega million, 10 to the 6th power is a million. All right, number 2, 3.1415926 expressed as two significant figures. Now, when we say two significant figures, it means that it only wants to see two digits of importance from the left, as in two non-zero digits of importance from the left. So what we should do, we should start counting from the left. So we have, this is our first digit, this is our second digit, and then we make a mark here. Let me erase that. We make a mark after that digit. So when we make a mark here, it means that these are our first two significant digits. And then everything else, we're going to turn them to zeros. Good. But first, what we need to do is to see if this number is a number that is 5 or greater. If it is a number 5 or greater, we're going to round up that digit. If it is not 5 or greater, it means that we're going to keep this digit as is. So what we see here, the most appropriate answer is 3.1. That's two significant figures. Okay. Number 3. All right, number 3, as it shows here, it says if force is equal to mass times acceleration, the unit of force could be written. So we want to determine here now, it says force is equal to mass times acceleration. And what you should know is it wants to figure out what would be the unit that we use here. Now mass, as you know, the SI unit of mass is kilogram. And acceleration, when we talk about acceleration of a moving body, it is measured in meters per second squared. Good? Or meters per squared seconds, I should say. So these are the SI units of these two quantities, mass and acceleration. And because we are multiplying, it means that we have to do the same thing to the units. So we're going to multiply kilograms by meters per second squared, right? And the unit here that shows what happens when you multiply kilograms by meters per second squared is the option D, right? So it gives us kilograms meters per second squared. So we're going to use that same knowledge to decipher number 4. It says the unit of electrical resistance is expressed as, and we have here 1, and we have this symbol, which is the symbol for resistance, right? And we have V and A, which is V represents voltage and A represents amperes. Good. So we're saying that an ohm is equal to watt. So that's the symbol for ohm, for resistance. So what you should know at this point to know this question, we must know the formula that V is equal to IR, where this equation is actually known as Ohm's law, right? That voltage is equal to the current multiplied by resistance. So it means now the unit of electrical resistance, you can rearrange this formula, which gives us that R is equal to V over I. And where R will be the unit, the ohm is the unit of R. So we want to figure out what are the units now. So V, which is voltage, is measured in volts. And then current, electrical current, I, should be measured in amperes. So we're going to have volts divided by amperes. So which of these units shows that? So looking at that division, if you turn them to indices, so V, and then that's A to the negative 1. If we turn them to indices and multiply. So V by A to the negative 1. So that's why A is our answer for this question, number 4. Right? So it shows the background knowledge that we need to have in order to do these questions. So leave that for a second. All right, number 5. Number 5 wants us to, it says the time period of a simple pendulum oscillating with a small amplitude depends on what? Now, what I wanted to know, this type of question, when you're talking about a period and a pendulum, that the main thing that influences the period of a pendulum is the length of the pendulum, right? The length of the pendulum. The mass, it doesn't matter what mass is attached to the pendulum, it doesn't influence the period, right? The amplitude of the swing, it doesn't matter the amplitude, it still takes that same period of time for a given length of pendulum, right? But what really changes the period of oscillation, that time it takes to swing from one point to an extreme point and then back to where it started from, is actually the length of the pendulum, right? Force with which the pendulum is set in motion, basically want it allowed to fall due to gravity on its own swing. So the C is our most appropriate answer there. Let's see, what's the next number? All right, number 6. Now it says, item 6 refers to the following diagram. So we have a graph here. We have a vertical axis Y and a horizontal axis X. And it says here, when X is equal to 0, the value of Y is what? So it's a case here where you have to understand graphs in terms of how to read graphs. So it's saying that when X is equal to 0, when X is equal to 0. So it means on our X-axis, we want to know where exactly is 0 found. Now, with a graph, the two axes are joined at the origin. It means 0, 0. So 0 on the X, 0 on the Y. All right. So this point here, this line going all the way up, these are values representing X equals 0. That's the X equals 0 line. So we want to know what is the value of Y. So we want to know where exactly does the line touch that line, the line drawn, or the Y line touch the X equals 0 line, which is here at S. Good? So answer should be B. B and not P. P is just telling you the coordinates for the Y coordinate for this point here. Good. So our answer here is B. Number 7. Which of the following will be constant if a constant net force is applied to a body, right? And in this case, the velocity will be the correct answer. All right, so next question, look at number 8. Now it says the Newton meter is the unit used to measure which quantity? All right, so we have force, momentum, moment of a force, and the power, right? Now, so what we're going to see here, it says Newton meter, right? Newton meter, which is Nm. And what we should really remember is which of the, these quantities here, what will be the SI unit. So we have force. Force is simply measured in newtons. Momentum is when we have mass multiplied by velocity. So that will be kilograms meters per second. And moment of a force is the force needed to turn or the force applied a given distance from the pivot, right? So it's a turning force. So that is force multiplied by distance. So that is meters. And then power is the rate at which work is done or the rate at which energy is converted. So that is given you in joules, right? So you see our answer here is C. C is our answer for that question, all right? Look at number 9. Which of the following expressions is used to calculate the efficiency of a machine, right? And then efficiency it's a ratio value which looks at the amount of work output over the work input, right? Is the work out over the work input. When we say work, we could still mean amount of energy, good, multiplied by 100, which gives you answer in a percentage when you multiply by 100. Now to find work output, right? That's the work done by the load. So that will be the force, load force by the distance the load moves. The distance moved by the load. All right. And then over the work input, and meaning the amount of let's say the work that the machine itself can do or is expected is capable of doing will be the input load. Good. Multiplied by the distance moved by input force. Good. Multiplied by 100. Good. So it gives us an answer there. We see our answer should be C. All right. So that gives us our efficiency. That's how we find efficiency of a machine. Look at number 10. Right. So it says item 10 and 11 refer to the following velocity graph, which shows a ball being thrown vertically upwards from the ground. Good. So in this case, we start to look about energy, right? When you talk about a ball being thrown upward, that's what you can gather from this question. We want to talk about energy, and it mentions velocity and a time. So that's the first thing you have to look at as well. You have to check to see what type of graph are you given here, and it gives you a velocity versus time graph. So once you get a velocity versus time graph, you have to know what sort of information can we get from a velocity versus time graph. And what you can see here in this question as well, with the graph as well, which is nice, is that it gives you in 2 quadrants, right? It gives you in quadrant 1, and as you should know down here is quadrant 4, right? In maths when you look at graphs. Now this is everything up here is positive, and down here will be positive, negative. All right. Now it's a case where you're saying the ball is being thrown upwards. Now, because it is being thrown upwards, it is going in the upward direction. It is acting opposite to that direction of gravity. Good. It is acting opposite to the direction of gravity. So it means that any velocity going upwards should be a negative velocity. Good. So that is what it is showing you here. This portion of the graph is showing that it has a negative velocity, right? Going from the time it is thrown upwards from the point P. Now, if you notice that as it goes upward, this is saying that the velocity is decreasing. The reason it is decreasing is because when you throw an object upwards, it reaches to a maximum point, a maximum height, where you just like in cartoons, you see that the object is going to slow down and pause for a second. Now that happens in real life, but it just happens so fast that we cannot see that lingering time. So at that point, when it reaches that maximum height, it's supposed to have gravitational potential energy. Good? Where it has stopped moving, the velocity is 0 at this point. The velocity equals 0 at this point. So at this point, from that height, it now starts to fall. And as it falls, the velocity is now going to increase. And it falls due to gravity, so it now has a positive velocity at this point as it starts falling. So if you notice, this portion of the graph represents as it starts falling from the maximum height x back down to a point q. So we want to understand, that is what the question is now asking. The point x on the graph shows when the ball is what? So the answer here that we can decipher is at its highest point above the ground, B, at the rest on the ground, C, just about to be thrown upwards, and D, on its way downwards. Good. So D. So our answer for this question, as everybody should have guessed by now, or not guess, but properly decipher, is A, at the highest point above ground. Right? That's how we get our answer for this question number 10. So what follows from it? Let's see. Number 11. Number 11, it says the gradient of the line PQ represents what? The gradient of the line PQ represents, so we want to find the gradient of the line. Now, without even looking at the graph, what we should know is what type of graph is it? It's a velocity versus time graph. Velocity versus time. Now, what does the gradient of a velocity versus time give? And from our notes, we should know, or from the textbook, when you read, you realize that the gradient of a velocity versus time graph should always represent the acceleration of the ball. Good. Let's look at number 12. A falling raindrop reaches a constant speed when right? And I think the answer for this question should be number 12. Number 12 should give us A. Right? So we have what is known as terminal velocity. Number 13. Says if an object is moving along a surface with a constant acceleration, the net force acting on the object is, we have A, 0, B, constant, C, increasing, and D, decreasing. Now let's see how we can decipher this answer here. So let's read the question again. It says, if an object is moving along a surface with a constant acceleration, so it means that the acceleration is some value. Let's say it is 5. 5 meters per second squared. Good? It is constant. That doesn't mean that the acceleration is zero. That is the mistake a lot of people make when we say acceleration is constant. Zero means that it is not accelerating at all. Good? So we're saying now it has a constant acceleration, let's just say 5, and the net force acting on the object is, right, so net force acting on the object is, so it means that there is a force acting causing it to change velocity. Now, acceleration occurs when there is a change in velocity. A change in velocity results in acceleration. So it means that a force must be constantly being applied in order for the velocity to change, right? So it means that in order for the velocity to increase, it means that there must be some bit of increase in force being applied on the object, right? So the force cannot be zero, the force cannot be constant, the force cannot be decreasing. If the force is zero, it means that the velocity may be decreasing, right? If the force is constant, it means that the velocity doesn't change, and if the velocity doesn't change, it means that the body is not accelerating. And therefore, that's why the most appropriate answer there should be C. That the force is increasing, which causes an increase in velocity, which, because there's an increase in velocity, there is an acceleration of the body. Right, Levin? Good. Number 14. Number 14, it says a glass marble X moving with a speed of 6 meters per second collides head-on with an identical stationary glass marble Y. What is the velocity of Y after assuming that X is brought to rest? Good. So with this question now, if you realize that this is a momentum question, right? And what you should know from momentum, or the principle of conservation of momentum, is that the sum of momentum before collision for each body is equal to the sum of momentum after collision for each body. So it gives you a general formula that m1u1 plus m2u2, that this is before collision, is equal to the sum of momentum of each of the bodies after collision. So m2 v2. Right? Good. So what are we saying here? Let's assume that m1 is x and m2 is y. Whatever their masses are, let's just say they're constant value. So the glass marble X moves with a speed. So m1 has a speed of 6 plus m2 is stationary. Y is stationary. So it has a velocity of 0. Good. So it means that the initial momentum before collision is m times 6, right? m6. Good. Now, after collision, we say that m1, which is x, is brought to rest. So then it becomes m1 by 0 plus, we want to know what is the velocity after, all right? So it becomes m v2. So that's m v2. So at this point, we're going to assume that m is equal to any value. Let's say m is equal to 2, right? So if this m is equal to 2 and that m is equal to 2, we're still left with 6 is equal to v2, right? Or the m's they can cancel out, and we're left that 6 is equal to v2. So that gives us the answer is C, right? So this question could be answered much faster, but is this, and what I'm showing you here is the knowledge that you need to acquire in order to answer a question like this, right? Number 15. All right. Now it says the rate of which of the following determine the power of a machine? right? The rate of which of the following? Now, the key word here in this question is the word rate. Rate. And in physics, when we talk about rate, it means per unit, per unit time. Good? Per unit time. It means that we're going to be divided by time, right? So it says doing work. So it's a case where you're saying work divided by time. Converting energy, it means energy. Converting energy divided by time. And then here we have change in temperature, delta T, divided by time. So we should have knowledge to see these formulas. Work divided by time gives you what? It gives us power. Energy divided by time also gives us power. However, the change in energy over time doesn't give us power, right? So we see our most appropriate answer there is 1 and 2 only. Okay, so that this is how we have to read and decipher questions. Let's look at one more question here. Question number 16. All right, which says, which of the following implements are designed to take advantage of a large moment provided by a relatively small force? A large moment, right? So large moment, it means that you have a smaller force being applied a given distance away from the pivot, where the pivot is located. So this is our pivot, our fulcrum, and then the distance is what helps to make the moment large, given that we have a small force. Okay. So what type of mechanisms can we use in order for us to have a large moment using a small force? So it means that we must have that the force could be applied a large distance away from where the pivot is. So we have a claw hammer. A claw hammer is one of the devices that we know. A regular hammer we call a claw. We have to use to take out a nail. You know, like let's say it goes this way, and then we have the hammer head here, right? So that's a claw hammer here. So this device, you know, we can pull at this point. We could apply a force here, and where we can pull out the nail at this location. Good. So the given distance is large, or is a given distance away from it. We have a crowbar, which follows a similar aspect. Right? If we have a nail here, we can apply a force at this point. So a large, a given distance, horizontal distance. Right? Pair of tweezers, we know how tweezers work. Right? Tweezers are small, we can use to pull out here. It's a shorter distance. Right? And we apply the force at this location. Sorry, that's not the distance. If we apply a force here, it's a shorter distance there. A pair of wire cutters. Right? Let's say how big wire cutters? Just like a scissors. Right? So wire cutters there. That's where the pivot is located. We apply the force at this point, this distance. So we have 2 and 4. Right? To the distance, we apply a small force that we could cut an object there. So our most appropriate answer there is 1, 2, and 4. 1, 2, and 4 only, not the tweezers. All right. So just that's just a quick preview of ways in which we can answer multiple choice question. I will do this again with some more questions for different parts of the syllabus. so we can see exactly what sort of knowledge and how we can go through to answer a given multiple choice question to get our most appropriate answer. All right, and to let you know that at this point in time, you need to know every single bit of information in the syllabus for each topic. Okay, so thank you for joining in. All right, see you next time.